today you're going to be taking some notes on slope. So go ahead and paste these into the next 2 pages of your math notebook, your spiral notebook. So we learned that slope is the rate of change between the rise and the run, or really it's the change in your vertical, which are your y variables, and then over the change in your horizontal, which are your x variables. So instead of writing change, you can actually use this triangle that is shortcut for change. And what you want to make sure is that when you have your slope, that you have your fraction should be written as a fraction in simplest form. So if that means that you have a fraction that reduces to a whole number, you want to write the whole number, not a fraction with a denominator. All right, and anytime you can stop these notes and record it. So the slope of a line can be determined from the table or by counting units on a coordinate plane or by subtracting coordinates. So if I want to find the slope between 2 points, 3, -2, and 4, 4, one option is actually to go ahead and graph these on graph paper, and then you can also count the vertical and horizontal change. When you're finding change of 2 numbers, though, what you're really doing is subtracting. So if I take my y values, which are -2 and 4, those represent the vertical change. So if I take those and I subtract them, -2 minus 4, I get -6. And then if I take my x values, which are my horizontal, represent the horizontal change, and I'm going to subtract those, 3 minus 4. And we get -6 over -1. And of course, if we reduce this, -6 divided by -1 is really just +6. If we had the points 6, 0, and -8, -1, again, I could graph them and then count the rise and run on a coordinate grid if I wanted to. I could also go ahead and find the change by subtracting your y's and then your x's. So if I look at my y coordinates, that represents, again, the vertical change, how far up and down it's going. So if I look at 0, -1, I do 0 minus -1. Of course, 0 minus -1 is really 0 plus 1. So that's going to give me 1. And then 6 minus -8, minus a negative is really a plus. So 6 plus 8 is 14. And so 1 over 14, there's really nothing I can reduce it. And since they're both positive numbers, it's a positive fraction. So that's just the slope of 1 over 14. If you have a coordinate grid, what you need to do is find any 2 points on that line and then go ahead and make your slope triangle. So I found these 2 points here. I make my slope triangle. I see that the horizontal distance is +2, and then the vertical distance is +3. We know it's +3 because the line is going up. So it's always my vertical distance over my horizontal distance or change, and so that's 3 over 2. For this one, I drew my slope triangle here, and I have a horizontal change of 2 between those 2 points, and my vertical change is -6, and I know it's a -6 because it's going down. And so if I put that in my slope, I know that my vertical change goes on top, so -6, and my horizontal change goes on bottom, which is +2. And -6 over +2 reduces to -3. Down here, again, find your 2 points, make your slope triangle. I see that here we have a +4 change, and here we have a +2 vertical change. So I'm going to put +2 over +4, and then that's going to reduce to 1/2. If I'm plotting the line, so let's plot a line that starts at the origin and has a slope of -3, label it A. So I'm going to start here. This is the origin. And if my slope is -3, that really means I need to go down 3 and over 1. Or you can think about, if you're looking at your tiles, I'm going to be decreasing 3 tiles for every case number. So if I go down 3, I'm going to go over 1. That's going to give me my next point. You can also backtrack and still keep it aligned. So instead of going down 3 and to the right 1, I could go up 3, but I'd have to go to the left 1 to keep it aligned. For the second line, we have plot a line that starts at 0, 4 and has a slope of -3, 4. So I start at 0, 4, which is right here. That's the point 0, 4. And then my slope is -3, 4. So I'm going to go down 3 and then over +4. And you can see that's going to create this decreasing line. The slope of a horizontal line is always going to be 0. We saw that with our function. When our function was always 3, it made that horizontal line of 3. And the reason it's 0 is because it's not increasing or decreasing. It's staying the same. Therefore, our slope is 0. The one that's interesting is the slope of a vertical line. So if you have a slope of a vertical line, you actually can't tell if that's increasing or decreasing. It's like falling off a cliff. I mean, there's no way to tell. And so you wouldn't say that's positive or negative because it's just a line that you can fall off of. I mean, it's not increasing or decreasing. And you wouldn't say it's zero because it's kind of like always changing. So we would actually say that the slope of a vertical line is undefined. Remember that if you want to move slope, up and right are positive movements. Look at this. The x-axis right here, the right side is the positive side, and on the y-axis, the up or the upward side is the positive. So these going right and going up are positive movements. We're going down and left are negative movements. And that kind of just follows along the number line. If you have a horizontal number line, left is negative, right is positive. And if you had a thermometer or a vertical number line, up is positive, down is negative. And you always want to make sure that you know that the steeper the slopes have greater absolute value. So the farther away that number is from zero, the steeper that line is. Okay, go ahead and try this. Graph 4 different lines, all with different negative slopes, and show each slope and compare the steepness. So go ahead and draw 4 negative lines and see if you can highlight the one with the steepest slope. Slopes will be represented with fractions with a greater absolute value. So the steeper the slope, the greater the absolute value is. So go ahead and do a sketch of all the different types of slope. You can draw a skier if you want to. So I want 2 lines that would be a positive slope, 2 lines that would be a negative slope, 2 lines that would be a zero slope, and 2 lines that we can't really define the slope. It would be an undefined slope. Okay, if you order these from steepest to least steep, the steepest line should be the line farther from zero, so the greatest distance. So 1/3, 3 over 2, which is really 1.5, okay, or 3 over 4. So 3 is going to be the number that's farthest from zero, so that's going to be your steepest. 3 over 2 is over 1, so 3/4 and 1/3 are both fractions less than 1, so this is our next steepest slope, 3 over 2. And then after that, we have 3 over 4. And then our least steep line would be a slope of 1/3. That's going to be the number that's closest to zero, giving us our least steep line. So go ahead and make sure you have these notes in your notebook.